important litmus test, not the only definition, but if you don't have enough information to write a test, then it's not done being specified.
Okay.
Thanks.
Well, I'll continue with the PDF. Is that okay? I think I can. It's available on the as markdown in Sync too. But we were using this. If you want, we can continue. Or if you prefer to move to the MD, we can use that too.
Does anyone have a preference on the call?
No, this looks fine.
Okay. So I think we had, if I remember right, I think we had ended somewhere around this section. The next section was the state machine itself. So this is something that we're proposing is implemented on the Sonic side. Here, I think it's it's a simple state machine, not much. So there's boot up, and then so there are two. I think I'll just point out what seems to be. Otherwise, it's very.
Hey, Sanjay.
Yeah.
Hey. Yeah, I just had a question I didn't get a chance to discuss last time. So if you scroll up, there was this data path synchronization, right? So yeah, just before we go to the next topic. Yeah, here. So here, this explains about the TCP fin packet, how it will flow through the DSC, like the DPUs, right? So, like, any thoughts on how it would work for UDP packets? Let's say if it's a blast of UDP traffic, right? Like, so, how is that handled?
Right. So till the connection is created on the primary and the secondary, and then the ACK comes back from the secondary, the UDP packets are forwarded to the secondary. But once the connection has been created, then the primary only forwards. There is no, it's short circuited.
Okay, so like until then, all the in-flight packets will just be forwarded via the secondary.
Via the
secondary. Right, that. Sorry, like that could be out of order if they are like be in flight that is through the second while we the flow.
I'm sorry, I'm not sure if it is me. It got cut off.
There's a little cutting up, yeah.
Yes.
Yeah. So sorry about that. So yeah, like Sanjay, like question was like if there are in-flight packets going through the secondary. And if the ACK came back for the sync, then that could be out of order packets, right? Like,
I think I kind of got you're saying till the connection gets established, whatever was in flight, whatever was sent to the secondary was getting looped back. I mean, was getting hairpinned back. Once it gets installed, at that moment, if there are new packets that come in that hit the connection, they will be.
Correct, yeah.
I think so. Balki, any this thing from?
Yeah. There will be. Yeah, if there are any packets after the ACK comes, they will be short circuited and there will be out of order. Yeah, it's UDP, which is basically kind of best effort, right? Yeah. So.
Oh, okay. Yeah. So yeah. Just want to make sure. Yeah. Okay. So there are out of orders that is expected in case of UDP.
Yeah, at that transitionary moment when from no connection state to when you get into a connection getting.
Yeah. Sure. Thanks.
Any other questions so far in the previous sections?
No, yeah, we are good. I think you can continue.
So here, I think the beginning is once I think the just to clarify it, just to set the stage, the state machine tries to handle both the active and the standby. So this is a implementation of the state machine. It's not necessarily sequence diagram of how the active and the standby are moving through the stages, right? Because that's cannot. So those are defined as flow message flows below in a later section. But this kind of covers the whole state machine as a whole. So it's kind of, I think you'll need to stitch together a little bit of, if the active was in this state, what would the standby be doing? I think we need to stitch together if you're just looking at the state machine in isolation. Just to keep that in mind, right? So here in this picture, so there are some external input that is happening, like for example, config being complete, or there are some other inputs that are coming from external distance. This could be from the GNMI typically. Other than that, there are also some, there is one direction. So this is running on Sonic. So there's one direction where there are API calls going towards the SAI SDK. So those are in these black arrows. And the SAI SDK itself I've represented as these orange bubbles on the side, right? So that it's running in its own thing, just for connecting what we are getting from the SAI SDK layer. It's represented in this orange bubbles. So initially, when the box comes up, there are a set of capabilities that need to be determined or exchanged between the peers, right? These capabilities themselves can be capabilities of inherent to the Sonic implementation, like version or what versions we support, things like that. There are also capabilities that the SDK, the underlying implementation, like for example, different vendors may have different capabilities or characteristics that they can interop with or cannot interop with the other side, the other peer. So those are some capabilities. So there is one stage where we're getting capabilities from the local side, and afterwards, when there is when we do see a peer and we are peering with the peer, there is an exchange of capabilities, and these capabilities are first processed on in the state machine itself to see if there are any if it's compatible at the top level capabilities level, and then the same peer capabilities are passed down to the underlying implementation via this SDK, where the underlying implementation may check its own do its own compatibility checks, right? So the expectation is each implementation may have different things. For example, one implementation may have a different set of parameters, right? For example, if it was AMD Pensando, we might have different parameters, what we want to validate against, sizes or other hardware capabilities that we want to make sure the peer is capable or not capable of. So we can either make it incompatible or even fine-tune what we sync across to the other side, right? Manage what we sync with the other side. So those can be done with the process peer capabilities check, and then the return value will say how to handle the capabilities, right? Whether it's incompatible or fully compatible or compatible with some new features disabled, things like that. Then, so I think here we have the boot up the init. So the init itself, there can be configuration errors. I'm just coming back to the first thing. So that was the capabilities, and there is a init. There could be configuration errors where, for example, the local IP or the peer IP is not configured, or the parameters are not correct, etc. So it could go back to a config error, and then a config complete, an external trigger that says that okay, the configuration is complete now. At that point, we do the recheck again. And then there is a stage where we try to connect to the peer, and there is a timeout. If there is a timeout, then the local node assumes that there is no peer, right? And starts going towards it. It becomes a standalone primary, right? And then when it is in standalone primary mode, it starts getting ready to, the node starts getting ready to forward traffic, right? To start building connection state and forward traffic. Right? In this stage, I think in this stage, either on the newly coming up node, which is on the left, or there is a standalone primary, which is on the right side, roughly. There could be a peer connect, right? And then when there is a peer connect, we move on to do some compatibility check of whatever capability we were talking about. And once it is established to be compatible, if it is not compatible, I think, again, it goes back to the configurer and wait for external resolution. If it's all compatible, then we get on to the state machine kind of triggers the bulk sync, right? So, via the start sync message to the underlying implementation. And then the newly coming up node, whatever is the node that is coming up, that triggers pulling of the flow state from the peer. Right? And once that is done, which is indicated by, because the whatever was the standalone primary side that knows all the state that it's syncing. Once that is done, there is something that is relayed back via the sync done or the bulk sync done message through from peer to peer to Sonic and then to the SDK implementation itself, the underlying implementation, which triggers the completion of the bulk sync. Just to note, during this time, there might be, I think, once we have set up the peer and when the bulk sync is happening, new flows that are getting established, they are still getting synced via the data path sync channel. I think we had briefly touched upon this in the last meeting. Here it is not evident in this picture, but I think we will see that in the message flows that are there. I think that it's more clearer there that there is also the data path sync happening along at this stage in the bulk sync. I think this was a request that we got when we were implementing from Microsoft, which was once the bulk sync is done, whether the node takes over whatever was its configured role is controlled by the controller, right? There is an API call from the controller. There is a call to say activate HA role. So after the sync is done, we don't take over the role itself. So if we continue, if there was a configured standby, which was primary forwarding traffic as the primary, we don't take over. And when the configured primary, let me call that the admin active and the admin standby, right? And then there is an operational state. So the admin standby was operationally active, right? When the active was not there and when the active is coming up, the admin active is coming up. At that stage, for the admin active to take over as the configured active, it is not done as soon as it comes up, but it is actually controlled by the controller. So there is more predictability and in the transitions. Right, so that is this activate HA role. And once the activate HA role is invoked, the state machine checks whether it is configured as primary or secondary. If it is configured as secondary, it does an activate secondary, lets the underlying implementation know what needs to be done, and waits for the underlying implementation, the SAI SDK or the hardware implementation to act back, and then it transitions to the secondary role. If it was configured as the primary, then there is an activate primary, which goes through the underlying implementation, comes back, and then transitions. So there are some activities that happen during activate primary. For example, if we have to the network control plane, right? For example, BGP, PFT, or whatever we are using. For that, the active might need to change the advertisement so that it starts attracting traffic, right? Those activities are done when the activate primary, when it transitions from activate primary to the primary. Any questions? There's a long monologue.
Yeah, so Sanjay, thanks a lot for this explanation. Just one quick question. I'm not sure whether you explained this one or not before, but I believe you're running this state machine, one state machine per ENI, correct?
Correct. Not per ENI. This is per VIP.
Per WIP?
Per VIP. If remember, we had said that there are two VIPs. The ENIs get associated to either one of the VIPs, where the states are mirrored. So on each DPU, there are two VIPs. One VIP is configured as active, one VIP is configured as negative. If you remember, I mean, as standby. If you remember the ENI-based load balancing we talked about in the previous time.
Right.
So each state machine is for each VIP. Each VIP is either in active or standby mode, primary or secondary mode. So there is one state machine per VIP.
But that doesn't make sense because you are essentially syncing and all those activities that you have mentioned in this state machine. It is these are all per ENI. So I would expect this one state machine per ENI.
Yeah, you could think of it as one step, one level of indirection. So there is all these ENIs. The ENI is associated to one of the VIPs, and the VIPs runs the state machine. Because when the node comes up, for example, we are advertising only a VIP into the network, right? We are not advertising per ENI. We are not advertising anything. What we control is only per VIP, right? So it's like a level of indirection. So indirectly it is associated to a ENI, but the ENI itself is associated to a VIP. So there may be 30 VIPs, that's 30 ENIs that are associated to a VIP. There's one state machine aggregate for all those 30.
But I want to ask this, clarify this, right? Because maybe between two VIPs there's there's a multiple ENI to be just between these two VIP pair, right? So but I think we when we do the sync we do not sync because maybe another in this VIP they have other ENI that is not replicated between these two VIP pair. So therefore we need to determine what ENI need to be synced, what ENI not, right? So
yeah, that's right. So if there were, for example, VIP A and VIP B, VIP A has 30 ENIs associated to it, and VIP B has another 30 associated to it. When this state machine moves and there is a bulk sync happening, it will be syncing the flows, for example, whatever is the activity is happening for those 30. Right, because
it's a union, right? So of this 30, right? So
correct, all for all the 30 years. Correct.
When we see this diagram, it looks like it is run per card, per DPU IPU, right? And then per card means there are two VIPs, and we basically are looking at the active one. So the active VIP comes into picture. So it will be like running this whole state machine per VIP, which is the active VIP, but overall it's for the card for all the active flows run.
Yeah, but at the same time, there could be, for example, one of the VIPs could be switching, could be it's configured as the secondary. So it would follow a different tree, right, different path. So that's why there is one state machine, although they are kind of some of their life cycle. For example, there's a failure or boot up. They are tied together, right? Their fate is shared. But the state transitions themselves are local to the VIP because each of them will follow different paths.
And when you say peer connect and these messages that are going back and forth, how are these messages carried? Will it be, what type of packet will it be, LLDP, TLB, for example, or what would it be in your case?
This is its own, there is a heartbeat message. We had one section for the heartbeat message above. I think we got, it'll be the same. Yeah, I think we can, I didn't put because it was this thing, but we can put some reference packet structure.
Okay. Yeah, that will be very important to have, to see how the messages are sent, how they're carried. Yeah.
Okay. So that is the heartbeat, but all these bulk sync messages, etc., those are there in the SAI and the below the gRPC channel that we talked about. Those messages are carried in this in these channels. That is defined below.
Okay, yeah.
Hey, Sanjay and Guhan, there was a mention that out of the ENIs that are mapped to a WIP, some of them may not be synced. Can you elaborate on that?
Because yeah, so each card advertises a single WIP, right? So, but between a pair of WIP, a pair of cards, right? So, for example, on card A there are 30 ENI, on the card B there are also 30 ENI, right? So, but it's not exactly the the replication is happening between these two cards, right? So maybe for card one, 15 of them are sync with card B, and then 15 is sync with card C, right? So therefore, between card A and B, when we do this, this synchronization, only 15 ENI need to be synced, right? So then between card A and C, then another 15 need to be synced.
Right. One thing though, Gohan, one thing I theoretically that could be, but I think currently what I would want to note here is our whatever the implementation that we have tried or whatever we have confidence in is we have these two pairs. So we have a pair of cards, and the pair of cards are sharing the same. It's not like a chain. So both WIP A and WIP B are shared between the same two cards, and the WIP A is primary on card 1 and standby on card 2, and WIP B is secondary on card 1 and primary on card 2. Yeah, theoretically, I think this can be extended to do it the way you're saying, where there are 3 cards in the or more cards.
No,
not
that you have a active standby setup, right? So you have because basically it's a slicing. You are not really replicating the just between two cards, right? So because one card cover 15 of them, another card cover another 15 of them, right? So
correct, yes. But today the peering relation is what we have tested, and this thing is between 2 cards where the WIPs are the same 2 WIPs are shared between the 2. But theoretically, the model can be extended to that, like what you were saying, right? Card 1 and card 2 share WIP A. Card 1 and card 3 share WIP B. It could be extended to that, but right now it is card 1 and card 2 share WIP A and B. That makes sense.
Yeah, but in that model, the ENIs will be mapped to the appropriate WIP, not to the
correct.
Right?
Yes, yes, correct.
So within a WIP and its peer, you always have the same set of ENIs that are mapped. Right? You will never have a case the other way.
Yes,
okay.
it's the same. Yeah, it's the same setup. Yes.
But it's still per ENI, right? So basically, this model primary and active is per ENI, right? So
yes, indirect, like you said, yeah, it's per ENI. It's not.
Yes.
Mm-hmm. So I didn't get this part. The last one. What if there is a switch over? Do we do anything? Once they get synced, then we can just switch over back and forth, or how does that work?
Yeah, so I think once it is synced, the data path sync is going on actively. At any point in time, there could be a switchover, either controlled or it could be unforeseen switchover, like some event bringing down the card or power going off or something like that.
So what is this last secondary wait for switchover, and then the line goes back all the way to the top?
Oh, yeah. So it is in secondary state where it is not forwarding for the secondary what the ENIs that are attached to the secondary, right? So what is happening in this secondary state? It keeps getting the sync messages from the primary, and it keeps updating the state. Right?
Uh-huh.
After this, if there is a switchover, then it switch over and then it becomes the standalone primary. Right, so it's actually the primary for the web, but it is in standalone mode because there was a switchover and we lost the actor. Right, it moves to standalone primary. Of course, I think after that the primary could come up again. During which state the secondary, whatever the standalone primary might have gotten new connections, could have changed state, etc. And when the other node, whatever was the peer, comes back again, the state is synced back to the from the standalone primary to the newly coming up node. At that point, the newly coming up node could become primary. Right, the state machine would restart on the other side. So there is one, if that makes sense, right? So there is a basically, right, fundamentally there are at least in this this relevant, there are three states, right? There is a primary state, there is a primary where we are actively forwarding traffic, updating the flows, and then syncing these flows. I mean, syncing the flow state to the standby. Then there is a standby state where we are receiving flow sync messages and updating our state from the primary. And then there is the standalone primary state where we are acting as primary in the data path. We are doing updating state, etc. But there is nowhere to sync to because the peer does not exist at that point in time. So that is the state which is a standalone primary.
Okay. So why is this secondary only move to, standard primary, not moving to primary directly? I mean, I could think, there could be, you could do switchover because of the failure, and you could do switchover because of maintenance, right? So there were two kinds of switchover.
Right. Yeah. So during maintenance, for example, what you're saying is we may need to bring down the whatever was the primary for some maintenance. During that time, we want to drain all the traffic to the secondary so that you can do whatever maintenance. And once that is done, you may want to switch back to bring that back. And during that state, it kind of, I think for simplicity of the state machine, kind of goes back to the standalone primary. You do whatever maintenance, and then when the primary comes back up, it has to restart everything because it has to pull all the flows from the other side. So it will, the primary, whatever was the one that was being maintained, would go back to the beginning of the state machine here.
Yeah, so basically when there is a HA relationship, high availability relationship, right, then the roles are called out as primary and secondary. Whenever one of the nodes go down, doesn't matter whether it is primary or the secondary, the surviving node will become a standalone because it's operating in a standalone mode. There is no peer for it. So in the standalone mode, basically the functionality is that it will forward the traffic, but there is nothing to sync to because it is operating in a standalone mode. Once the peer comes back up again, then the relationship is again established. All the states are synced, and then the roles are set to primary, secondary.
So could we have like two devices that both standalone primary because they lost connection to each other?
Yeah, so there is this if there is a network partitioning happens wherein each of the node doesn't see the other node, then it becomes like a split brain scenario where both of them will become standalone, and whatever traffic that lands on that, they will be switching traffic. But it kind of becomes tricky at that point because there can be cases where for some connections the forward traffic can land on one standalone and the reverse traffic can land on another standalone.
Yes. So there is this thing that go on. I think today's BGP, the way we are advertising, even though if there is just, let's say there are two levels of network partition, right? One level is, let's say there is network partitioning where just the control traffic is not able to reach from peer to peer, but the rest of the network is fine, right? So the actual data traffic can reach both. There is no network partitioning there. But for some strange reason, there is some network connectivity between the two nodes. Just for that, control traffic is broken. That also would lead to this active-active situation. But in that state, what this thing is, the way the BGP advertisements are advertised with the prepend, AS prepend, what happens is the network would then, in that case, decide, would always converge to sending traffic only to the configured primary, right? And it would switch traffic to the standby only when the configured primary stops advertising. That is one level of network partition. The second level of network partition is the network itself, even for the data part traffic and for all the control traffic going between. Everything is really, truly, actually, there is a partition in the network. In that case, even for this BGP advertisements, whatever we say, even that, there is no connectivity between the two halves, right? Between the two sides of this thing. Then that would be true split brain, where traffic could end up in either one of those.
So in the split brain case, when the traffic is broken between the two HA cards, paired cards, then based on the role that's configured, will it continue to act based on the role that is configured on the box, or will it assume active role?
It would assume active role, because once we lose connectivity, there is no way for, so if I'm getting your question right? So there is a card A, which was primary for the WIP. There's card B, which is secondary for the WIP, right? Then they lose connectivity. So on the standby side, card B, card 2 side, right? There is no way to differentiate whether it's a split brain situation or we actually lost the primary actually went down due to some fault, right? There's no way to differentiate. So it switches over to the primary, this thing. But there are things that we can do in the network, which is the BGP advertisements that we are sending. It can be such that even if the nodes themselves both go to standalone primary, if there is any network connectivity on the top, we can still influence such that the traffic always lands up on the configured primary if it is active. Yeah.
Right. So based on the WIP from BGP AS prepend side of things, they can be distributed across both the standalone cards.
Correct.
But it will forward for all the.
It will forward. Correct.
For all
if the traffic,
ANIs.
Yeah. If any traffic hits it, then it will. But hopefully, if BGP is if the BGP connectivity is still there on the network, then all the network would be sending all the traffic only to the primary side. So there is not really disruption. But the standby, configured standby would be in the primary state, but not receiving any traffic because the network is not steering any traffic towards.
But it will forward back.
Yes, if it receives any traffic, it will.
Okay.
No, I'm sorry, the last point, the forwarding back, right? Can you clarify that, Sanjay? So because of the BGP trick, the standalone primary will, when I say standalone primary versus the configured primary, right? Configured primary would be attracting all the traffic because of the AS prepend, but the standalone primary will not get any traffic, and there is no reason it would get any traffic to forward it back, right? The forwarding back scenario will not happen.
Will not happen. But in case it did receive, what I'm trying to say is from the state on the card, there's no difference between, we cannot differentiate between the two cases, right? Where we became primary because of losing the active or because of a network partition. We cannot differentiate on that card. So the card is ready to forward, right? If let's say the primary went down and then network started steering traffic towards the standalone primary, which was the configured secondary card, the configured secondary would forward traffic, right? Because it wasn't standalone primary state.
Yeah, it would forward traffic to the destination, not back to the primary. Right?
Not back to the primary, back to the destination. You're right.
Okay. Hey, one question. I don't know if you answered this. So the activate HA role is a separate trigger coming from the controller, right? So there is always a delta time between bulk sync done and activate HA role. So what happens to the new flows or flow updates that happen between this time?
These are we are continuing to keep the two sides in sync. So all this activate HA role does is it keeps it in whatever state it was, right? Whatever the state the network was. We are not switching over or doing anything, preempting, making it active as the configured, no, following the configured state. But if we were syncing from card 1 was active and card 2 was standby for the SWIP, but the configured state was the other way around, we would still keep it in the whatever was the running state till the activate HA role is invoked. So there is still traffic is still flowing. We are still continuing to keep it whatever was the state was before this, right? When we started doing this thing. So for example, if there were new flows that were getting created, the data path would be syncing it to the other side.
Oh, okay, it would. Okay.
Yeah, that will continue.
So when you get, for example, with the standby get lost, the the heartbeat and become standalone primary, and when there is a peer connected to this one, so how do these two nodes to decide which one is actually the primary, and which side do the state sync?
Oh, you mean when two standalone primaries, let's say they come back,
yeah,
I mean they detect each other when they are both primary.
Yeah. So the configured active is the one that will always sync the state in that case. So basically the state machine, when it is when the state machine detects that it is detecting, it's seeing a peer, and if both the peers see that they are in standalone state, then basically the node that is configured as the admin active, that is the one that will sync its state to the peer. Because the node that is configured as the admin active is the one which will have a better cost, right? It won't have prepend ASN, so the traffic will only hit that. So that will be that is the node that will have the updated state.
Hey, Sanjay, I have a quick question on this connectivity part, right? These DPUs are connected, connected to each other through two networks, right? As we discussed, one is a data path channel and another one is a control plane, right? One we said like a CPIP we were talking about, through which it is communicating all the data path packets. So the question here is
Is this what you?
Yes. So the question is, I don't know whether it's already explained, but heartbeat packets. Which channel do the heartbeat packets go through, and then do we have heartbeats for both the channels?
Yes. So actually, these one clarification here is this is although they are logically two different channels because the connections are different, but they are all going through the same physical network.
Okay.
Are they using the same IP or using different IP?
Using the same IP.
They are using the same IP.
Same IP.
Same IP. Yeah. Right. Okay.
Yeah.
So does the sonic help in the heartbeat? Sonic transmits and receives the heartbeats, or?
So that is something up for debate. So I think currently, we are thinking in this proposal that it is better the DPU handles the heartbeat because it could be very aggressive, and we could also use things like BFD offload and things like that. Yeah.
I was thinking of
that's
BFD.
up for debate. Yeah. So that's why we thought it might be better it is done at the DPU side, at the DPU.
So the control plane has to create the packet and send it to the DPU, and the DPU keeps resending that? Or?
Yeah, so it could be one implementation could be that's what carrying from what we have done now, right? Is the DPU creates the packet, manages the whole heartbeat, and only when it loses heartbeats, there's a notification that goes to Sonic to say loss of heartbeat or whatever is this.
So how aggressive is that? Is that like on the order of seconds or milliseconds, or?
It's in milliseconds now. Yeah.
Okay, on the
exact number it's configurable. Balki, do you know what it's configured to?
No. So currently, yeah. Excuse me. The exact number. I mean, the number that we have it configured is 150 milliseconds. But the thing is, it has to be tuned, right, based on what Microsoft's this thing, right, deployment requirement is. So that's why I don't want to give the number, but I mean, by default, it
In
will
that
come at
order.
150 milliseconds. Yeah.
Do you
That
plan to reuse the BFD infrastructure code in Sonic and everywhere, right? Do we want to reuse that, or is it a separate implementation? I guess we have not discussed that part.
We have not discussed.
Okay.
Today we don't use BFD, but it's done from the P4 side. It is done, but it's not BFD first.
Oh, but then we need to get this clarified in this design doc, right? So because you know, if it's a you know, if we're closing on using the BFD, I think the Sonic already have the infrastructure to do the BFD.
I think we should have probably another discussion on the heartbeat, on where we want to do the heartbeat. Since it was, I think, yeah.
Yeah, Gohan, James is working on this right now. Gohan with Michael.
The BFD in Sonic is, I think, on the order of 300 milliseconds. Is that fast enough for our purposes, or want to have a much faster type mechanism here?
No. I think the BFD on Sonic is support hardware offloading, so you can do as much as fast as you can in the hardware, as long as the hardware support.
Yeah, that is correct. But in the same time, if you're talking about millisecond in the DPU, that should also have to be through a hardware offloading. It can't be done in the software. Right.
No, but that's what I'm saying, right? So the Sonic's BFD is leveraging the hardware. It's a hardware BFD. It's not a software BFD.
It uses DX assist, hardware offloaded BFD.
Yeah. So you can meet any requirements that you want.
Maybe I think it might make sense to have another focused on the heartbeat, another discussion.
Yeah, sounds good.
Yeah, this is just kind of the proposal. Not everything's final.
Yeah.
Okay.
Hey, one question about the activate HA role. So yeah, can you clarify, like, is that message sent by the controller to the standalone primary, which is like configured as secondary? So this trigger will say you can now switch back to secondary, right?
Whatever
or
is
will it be? Okay, so or will it be sent on both nodes? Yeah, just trying to understand what the actual configured primary we will operate, right, when it comes up.
Yeah, the activate HA role will be sent to all the nodes, right? So first, when only one node comes up, it will come up as it won't detect any peer. So it will be kind of in the standalone, right? But it doesn't take over. Then the activate HA role will take trigger will make the node to take over as standalone, and it will be in standalone, and it will be switching traffic. Then when it detects the peer will come up. It will get the bulk sync from the existing node, and it will wait for its activation. So the controller will activate that node now, and at that point, it will become, based on its configured role, it will become either active or standby. So like you have two whips, right? For one of the whip, I mean, the way the two whips are configured is it will be active on one node and standby on the other node, and vice versa for the other whip. So normally when a node comes up, what is going to happen is for one of the whip, after the activate HA role, for one of the whips, it will go to standby, and for the other whip, it will take over as active, basically.
Okay. In short, it happens on both the nodes, both the sides. Yeah.
Okay. Yeah, I was just trying to understand the order in which it will happen, right? Like, so say one node was up and it is in the standalone primary, and the second node comes up, which is the configured primary. Like, will the controller, like, let's say the state is all synced up. Now the activate HA role first will come to the configured primary to ask it to become the primary, and then the next it will come to the standalone primary to change to secondary. Is that the sequence or?
I think what Balki was saying was, so on the configured secondary, which was in standalone primary mode, the activate HA role had already been invoked by the controller. Now the new node comes up, which is the configured primary. When it is coming up, the controller would come do activate HA role on the configured primary. Now all the state is synced up because it got the activate HA role. It would move over to whatever is the configured role and take over as the primary at that state.
I see. Okay, so then the activate HA, there is no event in the standalone primary
At that point in time. Yeah, at that point.
Okay.
So then in the standalone primary, we'll have to deactivate those flows, right? Meaning have to go back and identify those rows that it's not those flows that it's not supposed to have active role on, and mark it as such and stop forwarding, right?
Correct. There is, yes, you're right.
No,
So
I don't understand. No, sorry, I don't understand. There is nothing to be marked in the flow. Right? So, Sanjay, what are you?
I see. Oh, you mean keep the.
No, so what is going to happen is when the new node comes up, right?
Pre-emption.
Let's say the new node comes up. There is one node that is already existing and it is operating as standalone, and it has established connections and it is switching traffic. Now, when a new node comes up, the new node first, what it is going to do is it is going to get the bulk sync from the existing node, and it will wait in that state ready to be, basically it has been prepared up. It is ready, but it needs activation. Then only it can take on the role. So once the activation comes up, let's say it is configured to be the active, right? So what it will do is, if it is configured to be active, its VIP is not, VIP won't have prepend ASN, but the node that is already existing and switching traffic is having prepend ASN, because it was the only node it was switching traffic. Now when this active comes up and the activate role happens, it will move to the active role, and it will start advertising its virtual IP, which will be without any prepend ASN, and thereby traffic only will hit this particular new node that came up, and the traffic won't hit the existing node anymore after that.
Yeah, that's the right explanation, because what happens is that if you are a configured primary, then you are going to attract all the new traffic, all the new flows to you. But at the same time, what happens is that, because the bulk sync, only after the bulk sync, you basically, should be declared as active primary, isn't it?
So one thing I want to say here is that normally we have been going through what are the flows that we want to sync, and we are, we have already discussed previously that the flows that we are going to sync are those that are active on this card, right, to the standby card. There is a slight change here when, if you can scroll up just a little bit, I forgot the term that you're using. Yeah, the standalone primary, right? Once the standalone primary is acting, and then there is no identified peer for HA as yet, and when the peer is now connected suddenly, it has to bulk sync everything, not just its own active flows or standby flows, etc. Right? Because at the moment it's acting as it is playing the role of being active for all the flows in the yeah, exactly.
Both of us. Yeah.
So then so first of all, it has to do bulk sync of all the flows, and secondly, when the understand that the new active that has completed bulk sync, and then it raises the VIP that will be advertising to attract the traffic for the new active, right? But the standalone primary will still at that time need to continue to forward the traffic until the VIP starts to advertise the newly connected active, right? And also for the return traffic, basically, back to the VM. I think there's some more explanation that needs to go in there.
Right. So what would happen is, I think what probably for your this thing, right? So there was only one card, like you were saying, let's say card 2, which was acting as standalone primary for both the whips. Now
Right.
card 1 comes up, we sync everything for, I think there are 2 state machines, we sync everything. Once we do that, for one of the whips, the other card will take over as primary. So there is a preemption, which when the activate HA roll happens, it takes over as primary.
Right.
And for the other whip, it remains as standby. Card 1 remains as standby. On the other card, the original card, the card 2, one of the whips continues to be primary because that was the configured primary. The other one becomes standby for that.
Right. So this, when the whip starts to attract the traffic for the newly connected active, that message has to go to the standalone primary too, so that it can stop forwarding for all the.
Correct. Yes. Yeah. So there is some probably the preemption case not added, but there are some message flows here. When we get there, we can talk about what is the state for during switchover, how this goes through.
I'm wondering if I can break in here, guys. Is this a good place to possibly stop for the day? And also, we need to get into the SAI Spec at some point. What do you guys think? Pick it up next week?
Sure.
Or Andy, are you willing to do it again next week? Keep going.
Sure. Okay.
You are? Okay. All right. And go on saying we should discuss the new HA design using overlap ECMP. Oh, gosh, I don't even know if we're that far quite yet. What do you guys think about that?
Guhan, did you mean overlay ECMP?
Yeah.
Not overlap?
Yeah, I mean overlay ECMP, yes. Sorry, did I type it wrong or?
Okay, yeah, it's okay.
Sorry, yeah.
It's okay. So, yeah, this topic is huge. It's fascinating, the whole HA design. Probably everyone doesn't have time after noon today. Would y'all say you want to pick it up next week? Or would you like a different meeting for this?
We can pick it up next week. That would be good.
Next week's good.
Next week. Next week.
Yeah, I think we should talk about the SAI Spec and then the overlay based HA right next time.
I'll write that down right now. And I'll stop the recording. Excite Labs, did you guys have anything pressing?
No.
No, good. Okay. Well, then I'll stop the recording and, thank you, Sanjay, BJ, and B team for taking us through this. I think we got through maybe 3 pages. Yay.
Hey, one last question to Sanjay. Hey, Sanjay, from a smart switch perspective, is this going to be between switches, or if the switch has multiple DPUs within?
This will be per whip on the DPU, because the switch itself is not kind of doing the whip itself. The whips are local to the DPUs themselves.
But you could think of this as the DPUs can be sitting anywhere in the network, right? And if it happens to be inside a switch or inside an appliance chassis, it's irrelevant, right?
Yeah.
It really peers no matter where they are and how they're pulled into play.
I think we put that in the design HLD. You can pull that up next time. But yeah, thank you everyone for your time. And I'll send the recording out and everything.
Thanks, Christina.
Yeah, have a good day. Yeah, thanks, and thank you so much everyone for the questions. Okay.
Thank you.
Thanks.
Bye-bye.